So, good afternoon, everyone, and I would like to thank the organizers for giving this opportunity to speak in front of you. And I'll be talking about testing, measurement, and monitoring technologies for electric vehicles. And to begin with, let me say a little bit about our company. Test and measurement. Mic is on. Can you hear? Okay. Aarjay specializes in various types of test and measurement instruments and solutions for electronics and electrical testing. And we've been doing this for more than 20 years. And for the electric vehicle industry, we have solutions for testing the EV powertrain, battery, and so on. We also have, we develop customized solutions also for testing and industrial automation applications. Okay. So, to set the context, why did I choose this topic, test and measurement? Of course, that is the main domain in which we operate. But as we all know, the EV market is booming. There are several studies which have shown that the growth that we have seen in the last 2 to 3 years is in fact just the beginning of a very rapid growth that we will see in this sector for the coming decade at least. And definitely that's good news for all of us who are in some way connected to the EV industry. So there are a lot of the traditional EV companies are getting into this, or rather the traditional automotive companies are getting into this space by introducing electric vehicle options. Also, there are a lot of exciting new startups. And we have seen both of these types of companies represented at the conference. A lot of the subsystems for electric vehicles are being now developed in India. We have battery manufacturing, motor manufacturing that's happening here. So that in India, and that's also very exciting to see. So on the other hand, we have also seen news related to safety incidents. Fire incidents have happened on different electric vehicle platforms. The government has expressed its concern, and there have been regulations that have been put in place. So with this as a context, testing of the vehicles and their subsystems assumes a great importance. And further, if you look at the electric vehicle architecture, I have sort of divided it into the core systems which are sort of unique to the electric vehicles. So like you have the EV powertrain, you have battery and the related systems, you have onboard chargers, the charging, EV chargers, charging equipment and so on. And then you have the other automotive systems which may to some extent be common with the traditional automobiles. And today I will focus more on the testing of the core EV systems, which are the powertrain and so on. Okay, so what are the motivating factors to test the electric vehicle? Of course, I already talked about the safety incidents that have been observed. The automotive industry has always been highly regulated. There are a lot of testing and regulatory requirements in place. So that is, of course, one of the primary reasons why testing is important. Battery performance. We have seen several presentations about battery and battery technology. So with battery being the heart of the electric vehicle, the optimal performance of the battery is critical, and testing the battery thoroughly, therefore, is again very important. Range. We have heard the term range anxiety in the context of electric vehicles, so where the users may have some apprehension about whether the vehicle will be able to take them to their destination on the available battery charge. So again, testing the vehicle to ensure that the stated range is being met is also imperative. Reliability and warranty, I think these are somewhat similar to the traditional automotive applications, where in order to reliably give a warranty as a manufacturer, we need to thoroughly test the vehicle. And The charging infrastructure compatibility, there are different charging standards, charging methods, AC charging, DC fast charging. So as the charging infrastructure evolves, the vehicle needs to be compatible to one or more of these infrastructure types. And so testing for that is also important. So Aarjay being a supplier of test instruments, I sort of structured the presentation to look at, let's begin with what are the major types of test instruments that we see as being used for EV testing applications. So this is a short list of the major instruments that we see. By no means is this an exhaustive list. So we have programmable power supplies, which are very common for testing different subsystems, be that the motor, the battery, or the EV charger. Power supplies are basically, it's a AC or a DC power source where the voltage and the current can be varied to test your DUT. Then we have electronic loads, which are basically used to, for example, discharge your battery and test the performance of the battery. We have grid simulators, which simulate the AC, the grid or the AC source and the different anomalies in the grid. It can be a single phase or a three-phase. Battery cyclers, which are specialized equipment for testing the battery. And we also have power analyzers for testing the power and the power quality characteristics of your system. So besides this, of course, we have a whole range of other instruments also that are used. It could be oscilloscopes, data loggers, or data acquisition systems for logging the different parameters, calorimeters, and so on, right? This list is pretty long. Okay. So next, I'll move to I've taken up a few of the major subsystems of the electric vehicle, and I'll talk briefly about testing of those subsystems. So starting with battery as the major subsystem of an electric vehicle. Now the battery testing can be done at the battery cell level, module level, or pack level, depending upon your application. And the common instruments that are used to test the battery would be programmable power supplies, electronic loads, and battery cyclers. And on the right-hand side, you'd see which are the major parameters that I want to test my battery for. So we want to know the battery capacity to begin with. Then there are parameters like the open circuit voltage and the internal resistance. Temperature, we talked about fire incidents, so understanding how the battery heats up over different cycles is important. Then we have state of charge, state of health, and so on. Okay. And this slide talks a little bit more about battery cyclers, which are a specialized instrument for testing the charge and discharge characteristics of the batteries according to specific cycling profiles, right? And what is really important in a good battery cycler is the ability to precisely control the charge and discharging. And it also has built-in safety features to prevent overcharging of the battery, overheating of the battery, and so on. Coming to motors, of course, there are many different types of motor technologies that are used in electric vehicles. We have BLDC motors, permanent magnet motors, and so on. But there are some common testing technologies which are used, like a dynamometer testing, for example, is very common to understand the performance characteristics of a motor. So for a motor, we want to understand, okay, what is the level of torque and power that is delivered by the motor, the speed, range over which the motor can operate, and of course the efficiency of the motor, that is how much power is output by the motor as a function of the input power that is delivered to the motor. And this slide shows a picture of a typical, a motor test rig, which includes some of the test instruments which are integrated together into a more complex test rig. So this consists of a power supply. It also has a power analyzer and also a servo motor and drive to drive our test motor. So this setup allows you to test for the power, torque, speed, and the efficiency characteristics of your motor. Now, power electronics, there are many different types of power electronics modules in an electric vehicle. So you have the motor drive, which drives the controls the speed of the motor. Then we have onboard chargers. We have DC-DC converters, which change the level of the DC voltage as per the different systems on your vehicle. And to test the power electronic modules, we use programmable power supplies, power analyzers, grid simulators, and so on. And this is again a typical setup that we have used to test a motor drive. And the picture on the right shows the motor drive in green. And we have an integrated test setup which consists of a power supply, a sensor signal simulator, an electronic load, and all of these instruments are integrated together into an automated system. And there are two kinds of testing that are done with this setup. There is a low voltage test setup which basically simulates the sensor signal input to the motor drive and tests the output, whether the drive is able to correctly interpret the sensor signals that it is receiving. And the second is the high voltage inverter testing function, which basically varies the input voltage and then tests the output from the inverter side. Putting everything together from the previous slides, we look at an overall picture of the vehicle. And this slide has all the different systems, the battery, the motor controller, the onboard charger, and you can see how the different instruments can be brought together to test the different systems. So it's possible to test each subsystem independently, but it's also possible to integrate everything into a vehicle level test setup. And finally, I'll talk about a monitoring application for EV chargers. And this is basically the system being monitored is a DC charger, which takes a 3-phase AC input, and the output is a DC voltage that charges the vehicle. And the main instrument here is a power quality analyzer that simultaneously and in a synchronized manner can look at both the input side to the charger and the output from the charger and make measurements so that you can understand any power quality problems that may come up. And in fact, you can also understand how the charging or the usage of the EV charger impacts the grid. And so this kind of a setup allows you to do a 24/7 monitoring, so you can continuously monitor your charger as it is being used. So with that, I would like to conclude my presentation, and we work with all of these partners that I have shown in the slide, and I would like to thank all of them for working with Aarjay. And of course, EV testing is a huge topic, and I have tried to touch the tip of the iceberg here. And we are also exhibiting right here in the exhibition. So I would like to invite all of you to visit our stall. You can actually see the instruments that I talked about today. You can see how they work, and we can discuss further. Thank you.